Okay, this is our video on extrema on an interval, and we've basically talked about maximums and minimums in pre-calculus, and we've talked about it some so far, and we're just going to get more specific and make sure that we understand what an extreme value is and ways that we would look at them. So if we have a maximum or minimum, we call them extreme values or extrema. Extrema is just a plural, and it just means any of those kinds. So it sometimes get students that get stuck and can't figure out what to answer because it didn't use the word maximum or minimum. So obviously extreme would be a high or low value, the farthest you could be. So if we find them, we call that optimization. So we're finding the optimal values, largest or smallest, or different things. And so we're going to talk about how to do that using calculus instead of just tracing on a calculator. So absolute or global extrema. Now, if it doesn't say anything else, if it just says find the maximum, then that's what it means. It means the absolute maximum. So this is the function that is greater than, it's the place it occurs, y equals f of c. So f of c is the maximum. Remember, it's got to be a y value. If it's greater than all other values of f for all x's in the entire interval. So this is a maximum on an interval. Generally, we mean over the whole domain. And same thing with minimum. That place is smaller than everything else, okay? So then it must be the minimum. So if we look at this picture, this is kind of talking about or showing some extrema, and we're going to label some extrema here by looking at some different points. So we have, let's look at some clear points here. So let's look at not worry about the endpoints, so the endpoints are not going to be considered here because neither of these endpoints is the largest or smallest value. So we're not going to answer anything about A or F. But if we look at this and we're going to answer absolute, and then we're going to go back on this same graph and answer where we have relative. So for absolute, I'm going to answer that I'm just going to use red to show absolute. So absolute would mean the largest value or the smallest value. So for example, right here, where we have E, f of E, because that's going to be the value that's over here, f of E. So f of E is going to be our maximum. Okay, so f of E is the absolute max. And you can use max, which occurs at x equals E. So we do want to get in the habit of saying that because the maximum is always the y value, okay? So it's not going to be the x value. Where it occurs is at x equals E. And if you kind of use this statement all the time, you're going to make sure that you don't accidentally say the wrong thing. And then our smallest value would be right here, is where it would occur, and this is f of D. Now be careful, because a very common mistake is to say that the minimum is D comma f of D. We don't use ordered pairs ever, so we use the y value. So f of D is the absolute minimum, or min, again, which occurs at x equals D. So that's a safer way to say that, okay? So now let's talk about relative or local. So you'll see the words relative or local both used all the time. So make sure you understand that they're the same thing. These are points where the graph changes from increasing to decreasing or vice versa. Where on the other hand, absolute extrema are the highest or lowest points on the graph always, okay? So for relative extrema, the formal definition says if there's an open interval containing C and f of C is the maximum, then we call it a relative maximum. If there's an open interval that and f of c is a minimum, then we call it the relative minimum. So I like to think of it as there's a peak or a valley. In a very small certain area, do you have the relative max or min? So for example, if I were to look, and let's just use green here, so right here, this would be a relative min, because it's the lowest value in this little area. It's not the absolute minimum, it's not the lowest of the whole graph, but looking at just sort of this region, it's the smallest value, okay? So here you would also have a relative max, and again, it would be the y value. So f of c would be the value that we call the relative max, and the relative min right here would be f of b. Okay, we would not call it the point, we would call it those values. Now, even though f of e and f of d are absolute max and mins, they're also relative max and mins. Now, that's not always the case, because sometimes the absolute max or min might occur at an endpoint, and so that's not necessarily going to be a relative max or min, okay? So, some things to think about here. When we say some open interval, we mean if we could find some interval that doesn't include the endpoints, and this value is the biggest or the smallest, then it's a relative or local max and min. Relative extreme is a little bit different than absolute. Absolute is the largest or smallest on whatever interval we're picking. So even if we went back to this graph, like we could change things up a little bit. If I said, I want you to name the relative max or the absolute max or min, but I'm going from here to here, and that's the interval that I have. Well, in that case, this value is the absolute max, but the absolute minimum would actually occur here at this endpoint, okay? So they can occur at endpoints. That's going to become important later. Okay, so those are just some things. So relative max and min just has to be the largest or smallest in some little interval around it. And there can definitely be other ones that are bigger or smaller, but just in that little region we have that. Okay, so here looking at this graph, we'll analyze again this open and closed intervals, okay? So A says state the relative extrema of g of x. So relative extrema mean if I'm looking at basically the peaks and valleys. So you're going to have a relative minimum here and here, because those are both valleys. So we would say we have relative min of -8 at x equals -3. We have a relative min of 0 at x equals 4. Again, do not say it's a point. It's never an ordered pair. And then if we have relative max, the relative maximum would be this point right here, because that's the peak that we have. So we have a relative max of 2 that's at x equals 2. Okay, so again, y value, y value, y value. Then it says, considering the entire domain for g, what are the absolute extrema of the function? So looking at this graph, we can see that we definitely have a minimum value. That's the smallest value, -8. But because this goes up on both ends, there can't be a maximum, because we're talking about over the whole domain. So the absolute min is, again, -8, which occurs at, or you can just say at, but I kind of like saying which occurs at, because it helps you remember that that's where it happens, not what it is. Okay, so the absolute min is -8, which occurs there, and then the absolute max, there is not one, because g of x is unbounded above. So there's some words that we've used before, bounded, and so it's unbounded above. So that means it just keeps going over and over and over, so there's nothing that's the biggest. Okay, next example, we want to consider this graph from 0 to 12. So now we have endpoints. So we want to find the relative extrema and then absolute extrema, okay? So relative extrema. So relative extrema, again, either look at peaks and valleys, or also it's where the function changes, like here, from decreasing to increasing. So therefore, this is a relative minimum. Right here, we change from increasing to decreasing, so there's a relative max. And here we change from decreasing to increasing, so there's another relative min. So we have a relative max of 7 at x equals 7, a relative min of -2, which is at x equals 2, and we have a relative min of 2 at x equals 10. Okay, so pretty simple to find the relative ones and so on from a graph. Now, absolute. So absolute maxes or mins can occur either at one of those relative max or mins, or it could be at an endpoint. Now, in this case, it's definitely not at an endpoint because it stops too early. So your absolute max is here. So 7's the biggest value, -2 is the smallest value that it has. So absolute max of 7 at x equals 7, and an absolute min of -2 at x equals 2. So it definitely, a point can be both a relative or absolute max or min. Okay, so then what must be true that we make sure that we have an absolute max and an absolute min? So what has to be true for us to be sure that we have both of those, that we know that we're going to find them on the interval? So extreme value theorem is what this is called. If f is continuous on an interval, so again, we always have that stuff that's important. In order to use this theorem, it has to be continuous on a closed interval. So this is important. It has to have endpoints that are included, okay? Then f must have both a maximum and a minimum on the interval. And that's really easy to see. We're going to look at some examples about when the theorem is included or not included. But an easy way to see that is if something starts and finishes somewhere and it's continuous, then it's either you have a minimum and a maximum, like in this example, or I have a minimum on the left and a maximum right here, or it's higher here and then goes down and back up. I mean, there's no choice, okay? So if it's continuous, I have to have one of each, okay? So here we're going to say, when does this theorem not work? Why does it not work? And then see if we have extrema. So the theorem may not be able to apply, doesn't mean we don't have a relative max or an absolute max or min, but to say that we have to have them, the function has to be continuous. So the extreme value theorem here does not apply, and that's because, I guess it doesn't have a name, just why. I mean, I guess we could just call it f, and then we could call the other ones different letters since it didn't tell us, because f of x is not continuous on the interval from 0 to 3, okay? And that's the first criteria. It has to be continuous. It's not. Now, can we find extrema? We can find both here, but that doesn't mean that we just weren't guaranteed them. So the minimum is going to be, we'll call that 1/2, and the maximum is going to be 4. So we have an absolute min of 1/2 at x equals 0, and we have an absolute max of 4 at x equals 1, okay? Next example, here we have, again, the extreme value theorem does not apply And then instead of saying because, I'm just going to put parentheses, not continuous on 0 to 3. Okay, so it's not continuous. So again, doesn't guarantee, all right, that we have a maximum, but we could. Well, here's an example where we definitely have a maximum, but we don't have a minimum because that point doesn't exist, and we don't know the next point closest to that. So we only have an absolute max of, we'll call that 4.5 at x equals 0, and we have no absolute min. Okay, so that's important. Again, it was not guaranteed. Sometimes we have both anyway, but in this case we don't. Okay, next example, C, the extreme value theorem does not apply again. And that's because not continuous on a closed interval. So you have actually both ends that mess that up. One end has a arrow that goes on forever, so we aren't going to ever end on that side, and then we have an open circle on the left. So in this case, we have no extrema. So that's my quick way to say I don't have both. Okay, extrema is the plural. So I have no extrema because I have an open circle here and an arrow that goes down here. So I have no extrema there. And then for D, we have extreme value theorem does not apply again. And here the reason is because it's not continuous at the end points. In other words, it's only continuous on an open interval. Okay, it has to be continuous on both ends. And we have a max and a min. So we have an absolute max of 4 at x equals 1-ish. That didn't look like 1 to me, but we'll call it that. And we have an absolute min of 2 at, again, doesn't really look like -1 exactly, but we'll call it that. Or sorry, absolute min of, we'll call it -1 ish at x equals 2. Okay, so the extreme value theorem just doesn't mean that we can't have both a max and min, but we aren't guaranteed that we will have both if we don't have that continuous. So if they are continuous, then we can find them. Okay, so sometimes we have to find where things exist by using algebra. And so we're going to look at, we don't have the graph of this, so we're going to decide whether we can or can't apply that theorem. So in this first example, 5a, again, we're supposed to justify why it can be applied or why it doesn't apply. Okay, so we're not finding the maximum, just can we do it? Well, clearly on the interval from -4 to 4, we have a discontinuity. So we would say, again, an intermediate value theorem does not apply for f of x, because they called it that, on -4 to 4 inclusive, because f of x is not continuous at x equals 2. So you would need to say where that is, and that's in the interval, so therefore that won't work. So if we look at this one, e to the something plus 1, if we go from -5 to 5, well, e is a continuous function, continuous everywhere, so we can simply say g of x is continuous for all real numbers. So the intermediate value theorem can be applied. Now, it doesn't say to find it, okay, but it can be applied. We're not finding them yet. Okay, on this interval, this does not work because of our domain. So we know that x plus 2 must be greater than or equal to 0. So x must be greater than or equal to -2, because underneath the radical can't be negative. And the interval that we're talking about is here. So again, h of x is continuous only for x greater than or equal to -2, so intermediate value theorem cannot be applied. Okay, on this interval. Okay, so it doesn't mean it can't be applied ever, but it can't be applied on that interval. That's important. So now we're going to talk about critical numbers, and we'll do an example, and then we'll probably finish the rest of these in class. So critical numbers are the places where it's possible for there to be a relative max or min. And the way that would be is if the derivative is either 0 or it does not exist. That's the only way that that can change from positive to negative or negative to positive. All right, so again, critical points, and we'll kind of look at them. So these are theorems that are important though, because this is how you can justify things without having to, again, say a whole bunch of stuff. So relative extrema can only occur at a critical value on an open interval. Now, that does not mean every critical point has a relative extrema value, but they can only occur there. So that's why they're going to be called critical points, because those are the places that we're going to check and see if it does in fact change from increasing to decreasing or vice versa. Absolute extrema must occur at either a critical point number or at an endpoint of an interval. So often the way we're going to tell they're asking us for absolute extrema is because we're going to have an endpoint to test. So we're going to know that that's kind of a thing. So we're going to talk about what we call a candidates test. And that's basically a list of, well, where is it possible that we could even have a max or min, a relative max or min. So example 6. Now, here's some importance. So this is asking for absolute max or mins. Okay? So actually, we're not going to do the candidates test because this is asking for absolute max or mins. So if we're asking for absolute max or mins, we just read a theorem. Theorem says they can only occur at an endpoint or a critical point. So first step that you're going to do anytime something says find a max or min or any kind of extrema, absolute, is I'm going to find the derivative. So when I take this derivative, then I'm going to say, okay, relative max and mins can only occur at a critical number. Critical numbers are where the first derivative is 0 or undefined. Absolute extrema can only occur at one of those places or an endpoint, okay? So what we're going to do is this one can't be undefined because it's a polynomial. So we're going to factor in order to determine our to see if we have where the zeros are, to find our possible places that we could change and have a relative max or min. So first thing you should do to this problem is factor out a 3 and make sure you're paying attention to that. The very first step in factoring, always get out the greatest common factor because you don't want to end up making the problem difficult. So when we do that, then we're going to look for factors of -24 that add to -3. So that's going to be, you have -24. Remember how to do factoring, so I'll just review it a little bit. And we want the sum to be -3. Oh, wait, I wrote something wrong. Oh, this is a 6. I was like, wait, that doesn't make sense. So sorry, that was supposed to be a 6 and this would be a 2. That makes a lot more sense. So make sure you correct that. Hopefully you're watching and paying attention and not just zipping through this. So that makes a little bit more sense. So I need the sum to be -2. So we know it's 4 times 6. It's a -2, so that has to be -6. So a reminder, these first two terms here are either 1 times 8 or 2 times 4, because I have to end up with 8x squared. 8, though, does not divide into either one of these, so this has to be 4 times 2. So 4x and 2x. My outside product has to be one of these things. Well, 4 divides into 4, not into -6. So we need to make a 4 here. And then 2 times something has to be my other term, so that's the -6. So that makes -3. Remember to watch the video on factoring if you still struggle with that. So that means x equals 3/4 or x equals -1/2 would be what we call the critical points. Now when I'm looking for absolute extrema, then what I'm going to do is I'm going to make a table, and I like to make the table going down because we have a theorem that says the only place that you can have an absolute extrema point, an absolute max or min, is at the critical points or the end points. So we have an end point of -1, we have a critical point at -1/2, we have 3/4 as another critical point, and we have 2. And so for the end point. So whatever is the largest answer is going to be the maximum, and whatever is the smallest is the minimum. And that's only true because it's absolute. Okay, so for absolute extrema, it occurs at a critical point or it occurs at an end point. So basically all I do is literally just plug these in. And so I'm going to just give you the values. It's a calculator question. So you still have to write this. This is very important. Okay, this has to be written to show that I'm testing all of these things. But then when you do the work, of course, on a calculator question, just type it in the calculator, write your answers, and then answer the question. So this is my work that's all shown. I showed how I got the critical points, and then I'm showing that I tested the candidates. So I plugged everybody in. And so in this case, I'm going to have an absolute max of 36, and I'm going to have an absolute min of -3.063 because that's the smallest value. So absolute max and mins are the easiest ones. We'll do relative max and mins on the next section. All right, so let's just do one more of these, and then we'll probably do the other ones in class, so we just have kind of a review. So let's actually do C down here. And so we have h of x equals sine squared minus cosine. And so we want to solve. Now, if this was if it's truly a calculator question, then I would want to go ahead and let the calculator solve and find those values. So you would literally just, in the calculator, say solve d dx and then put in that function. So here I'm just going to go ahead and give you the answers, and I want you to actually practice. So I want you to take your calculator, and I want you to actually practice solving the derivative equal to 0 and make sure you only answer for that. Okay, so remember it'll be solve d dx, and you got to put in the function equal to 0, that derivative equal to 0, and then make sure you do the vertical bar on the outside, and x goes from 0 to 3 pi over 2. So I want you to practice that. Then I would use my calculator and I would just find these values. So I would make this table, and so I would need to put in endpoints. Well, 0 is an endpoint and a critical point, so it doesn't have to be there twice. And then I know I would have 2 pi over 3 is less than pi, and then I have pi, and then I would have 4 pi over 3 would still be in the interval, and then 3 pi over 2. So just make sure I get them in the interval. So 0 to 3 pi over 2, and then getting my values in there. And so again, I'm going to give you the answers to this. If you need calculator practice, this is a great time to practice. But here are the answers, so you could pause if you wanted to practice and get the answers. And so here we would have an absolute max of 1.25. Now it occurs at more than one place, that's fine, because most of the time you're just asked what's the max or min, not all the places that it occurs. And then we have an absolute min of -1. And that's it. So we'll do the other questions in class. So that's it for the video on extrema on an interval.